Okie dokie, we are rolling with our Zoom. Okay, remember that bell ringers are for virtual students and all of us. So on the first one, it says find the measure of each numbered angle. So number 1, how did you find angle 1? Okay, so you got to find 2 first, because you know this is 90. Good. So 90 minus 53, what's that give us? 37. So that's angle 2. Okay. Well, you know that this one's 74. So what is 37 plus 74? 101. Oh, okay. 3 ones. 111. Okay. And then you have to take that from 180 because every triangle has 180 degrees. And what does that leave you with? Perfect. So that is angle 1. So we actually have 1 and 2 now. So how are we going to find 3? Good, because these two are a linear pair. So you've got 180 minus 74, and what's that going to give you? 106. And then how do you find angle 4? Okay, so you know that all 3 of these have to equal 180. You could have also done the big triangle 90, 69 and gotten the answer. So there's a couple of different ways to get that one. But what's 106 plus 53? 159, and then you take that away from 180. What's 180 minus 159? So that is going to be your answer. Questions on those? Okay, then for number 2 on the bottom, what did you have to do for number 2 on the bottom? Add them all up, they're degrees. So all the degrees on the inside of a triangle equal 180. Now, just to be lazy, I'm not going to write it all out. I'm just going to add the x's together. So 2x and x and 3x gives me 6x, and then 9 plus 5 is 14. Hold on, let me end that. Zoom, perfect. Okay, where was that at? 9 plus 5 is 14, minus 2 is 12. That equals 180. Then you subtract 12. 6x equals, divide by 6. 20 even? 28. Okay, so that's x. What does it want? Find the missing variable. Okay, so that answers the question. That the x is 28. Okay, over here on B, what are we dealing with on letter B? Okay, because the sum of the non-adjacent sides is congruent to the exterior angle. So this is the exterior angle theorem that we learned. So when we add those two together, 60 plus 3x minus 13, that's going to equal the exterior angle, which is 5x plus 1. Okay? So then over here, we combine our like terms. What's 60 minus 13? So negative 47 plus 47, thank you, because 60 is positive. Then we just work it out. So I'm going to subtract 5x. That's going to give me negative 2x. Then I'm going to subtract 47, which is going to give me negative 46. Divide by negative 2. What does x equal? Positive 23. Y'all remembering all of these? See, we've learned so much this year. All right, cool. Okay, so get out your textbook. Hopefully everyone remembered theirs today, because we are back in it and we will be for the significant future. I do have to backtrack with this class because I was wrong yesterday and I need to fix my error. So everyone go to page 243. I realized it the next class period, so I want to make sure that I clear that up and don't lead you guys astray. I also fixed the digital book. I don't know if you guys clicked on it yesterday. Several people emailed me and said that I'd messed the digital book up. I did. I uploaded Algebra 2. So when you clicked on it, it was Algebra 2's Unit 3, not Geometry's Unit 3. So I fixed it in case you ever need that. Okay, so like I said, yesterday we were talking about dilating and having a scale factor, and we multiply by the scale factor. That's what we were discussing yesterday. So we are going to just start right here at number 13 so that I can make sure that I present this material correctly to you. Okay, triangle RST. It gives you the ordered pairs. This is where the pre-image is at, okay? It says is mapped onto triangle R prime, S prime, T prime by a dilation. We talked about yesterday that the image is on top, the pre-image is on the bottom, okay? The distance of a side, okay? If we were talking about, you know, just a triangle on the ground and we were trying to compare, we could get a ruler out and compare the lengths of all the sides, compare the lengths to the other image, and see if they are proportionate. Your sides should be proportionate to one another because, like, if I draw two rectangles that are seemingly similar, they look like they've been dilated, in order to figure out how much they've been dilated, you would first of all need to know which one is the pre-image and which one is the image. Because if all I told you was that this is 2 and this is 4, what are the possibilities that it could be for a scale factor? 2 or 1/2, okay? Because not knowing who was first, you could say, well, 2 over 4 gives me a scale factor of 1/2, or 4 over 2 gives you a scale factor of 2. So it's very important that you know who is the pre-image and who is the image. Well, when you're looking for that, look for the little prime mark, okay? The prime mark means that is the image. That's the after, okay? That's the one that has been dilated. So if that's the case, the 4 is going to be on top. The 2 is going to be on bottom, which means our scale factor is 2, okay? So in this case, they've given it to us here. We've got 5 over 2. We know that's our scale factor. Is it an enlargement or a reduction? It's an enlargement. That's the same as what we talked about yesterday. Anything that is greater than 1 is going to be an enlargement. So 5 over 2 is 2.5. Well, 2.5 is greater than 1. It is an enlargement, okay? Now, this is where I messed up yesterday. So it says here, if this is 5 over 2, so this is the scale factor, and R prime is at 0, 0, okay? Well, R was originally at 0, 0. What's 0 times 5 halves? What's 0 times 5 halves? So that's going to stay the same. It doesn't change because it's the origin. But then it wants us to find S prime. Well, instead of drawing it out like I did and saying it's 5 units apart, we have to actually use the given ordered pair. So you go back to the original S, and you're going to multiply both the X and the Y by the scale factor. So what's 0 times 5 halves? That stays the same. What is 4 times 5 halves? So your ordered pair is actually at 0, 10. Not like what I said. Don't measure it out. Don't count 5 units. Don't do it that way, okay? Because even though that's the ratio, that doesn't necessarily mean it's going to be the length of the side. It just means the ratio is 5/2, not specifically this has to be 5 units long, this has to be 2 units long. Obviously, this one is 10 units long, so that means the other one is only going to be 4 units long because 10/4 is the same ratio as 5/2, right? Okay, so don't get too caught up in all of that, but just know that when you're looking for a next ordered pair, which is what you're going to be doing here in a second, when you're looking for those ordered pairs, you have to multiply by the scale factor. Multiply the x by the scale factor, multiply the y by the scale factor, okay? Now, let's go to C. We didn't get that far yesterday. It says triangle RST is mapped onto R prime, S prime, T prime by composition of transformation. Composition of transformation just means we're stringing these things together. We're doing multiple transformations. So it says triangle RST is dilated by a scale factor, 5/2, and it's followed by a translation. Then it gives you the translation. What is another word for translation? Slide, right? Remember we did translations where we slid them? So what does the +2 tell us that we're doing? Right, 2, because the y tells us up or down. So y means we're going down 5. So that's the slide that we're dealing with. But what do we do first? A dilation by the scale factor 5/2 followed by a translation. So what's first? The dilation. Okay, so here's a good way for us to keep these organized. So when you're doing this and you've got multiple things to do, you can make yourself a table. So this would be like the originals. Okay, this is your start or the pre-image if we want to be correct. Okay, so we're taking notes. Everyone's doing what I'm doing. Y'all are writing. This is like our lesson. We're back into this. So our pre-image, okay, is located R at 0, 0, S at 0, 4, and T at 3, 0. You could map it if you wanted to and like actually plot your points, but I think a table is going to serve the purpose and help us stay organized. So the next thing that we're doing is a dilation. And our dilation is what scale factor? Multiplying. And what are we multiplying by? What is the scale factor? 5/2. So you're going to multiply 5/2 times the x, 5/2 times the y. Because when you're doing a dilation, you multiply the scale factor by both the x and the y. And you do that for each one. What's going to be 0, 0? 5/2 times 0 is 5/2 times 0 is. Now for S, you have 0, 4. 5/2 times 0 is 5/2 times 4 is 10. We talked about that one just a second ago. Then we do T. 3 times 5/2 is 7.5, and you can give me that because it's a good decimal. And then 5/2 times 0 is 0. All right, so we did our dilation. Following the dilation is when we do our slide. That's going to be x plus 2, y minus 5. This is our slide or our translation. So then again, you're just applying that rule to each ordered pair. So what is 0 plus 2? What's 0 minus 5? That is going to be S prime. No, not S. What letter are we doing? R. Thank you. Okay, then what's 0 plus 2? What's 10 minus 5? Positive 5, and that is going to be S prime. What's 7.5 plus 2? 9.5. What's 0 minus 5? and that is going to be T prime. So using that table is going to help you keep your work organized, make sure you're doing the right thing. If you're applying a dilation, you multiply the X and the Y. If you're doing a slide, you follow the rules that you already have learned. Okay? Now, number 14 down here says, did we do that one yesterday? Number 14 says, describe the dilation with a scale factor of 1. What's going to happen if we have a scale factor of 1? It's going to stay the same. There's going to be no change. If your original point was at 2, 4 and your scale factor is 1, it's going to be 2, 4 because 2 times 1 is 2, 4 times 1 is 4. So it's going to stay the same, no change. Basically, you're making a duplicate. Okay, if we were talking about pictures like we were yesterday, you just have 2 prints, the exact same size. There's just 2 of them. They're duplicates. Okay, no change. All right, so now let's move on. That gets all that taken care of. And today we're going to be talking about the center of dilation. Okay, so center of dilation, where we are most comfortable with, is when the center's at 0, 0. Obviously, that makes things simple, but you can change that to be whatever you want it to be, and that's what we're going to talk about. Over in the math terms, it says the center of dilation is a fixed point about which all points are enlarged or reduced. So that point is staying the same. That's why 0, 0 in the examples that we saw stayed 0, 0. It just didn't change because that's what our center of dilation was. It says here that in each of Kate's layouts above, the center of dilation is the origin. Now she considers some dilations where the center is not the origin. Kate wants to dilate the triangle ABC with a scale factor of 2 and a center of dilation at -2, 4. Okay, so she's identified the point that she wants to use as -2, 4. That's not going to change. Everything else around it is going to change. That point is going to stay the same. And our scale factor is 2. So if my scale factor is 2, what's going to happen to my image? It's going to double. It's going to be an enlargement. Okay, our image is going to become larger by 2. You can see the image there. You can see A. It says, when the origin is not the center of dilation, you need to subtract the coordinates of the center of dilation. That's step 1. You need to subtract the coordinates of the center of dilation. Okay, so whatever the center of dilation is, you're going to subtract those coordinates from the coordinates of the pre-image. Then, step 2, multiply the difference by the scale factor. Then, step 3, add the coordinates of the center of dilation. So it's a 3-step process for doing this. Basically, you take it out. By doing that, you're going back to 0. You are taking your image and you are putting it back to 0. So if I was going to just show you an example, a quick example of this, if this is my square, okay, and I want to center it around this point, 1, 2. I want that to be my center of dilation, 1, 2. Well, what I have to do is get that back to the origin so that I can apply the dilation. And then once it's back at the origin, I've applied the dilation, then I'll put it back in its spot. So to get this to the origin, I have to go left 1, which is subtract 1, and then I have to go down 2. Subtract 2. So you're actually subtracting this ordered pair. It's going to get your square back to the origin. Okay? Then you'll double it, whatever it may be, triple it, whatever. After you've done that, you'll take those ordered pairs and add it back. Add 1, add 2, and then you're back to that same spot. But you don't have to do that all graphically. That's what's happening graphically. It's like you're taking whatever your shape is, wherever it is, and you're taking that spot that you want it to be centered at, and you're pulling it to the origin. You do that with subtraction. Once you've done that with subtraction, apply the dilation, multiply whatever it is. Then you undo the subtraction with addition, and it goes back to the right spot. Okay, so I like to personally do this with a table because I like to have tables, but the book has given you a formula. Okay, I just personally can't memorize all of these formulas all the time, so I'm going to show you how to do it with a table and then also show you how to do it with the formula. So you've got two methods. Because on the ACT, you guys just have so many things to remember. I don't want to add one more formula. I want to show you how you could do this just by common sense. So number 15 asks you to find the coordinates of the vertices. So list me the coordinates A, B, C, and D for number 15. Okay, where's A? -2, 4. Where's B? And where's C? Okay, and what is our scale factor? What did it say up there that we're multiplying by? It's somewhere up there. Isn't it 2? Okay, so we're doubling this. Our scale factor is 2. And where's the center of dilation? -2, 4. Which basically means this point is going to stay the same. A is going to stay consistent. Everybody else is going to be moving, but A will stay the same. Now, we can see that using their equation that they gave us here, because number 16 says, what are the coordinates of the image? So we need to apply this dilation. So it tells you that X and Y is your pre-image. So X, in this case, would be -2, and Y would be 4, because that's our ordered pair. Then AB is your center of dilation. So our center of dilation is also the same thing. Okay, so then we would just plug it into their formula. We have A plus K, X minus A. That's going to give us the X term. So A is -2 plus K, which is our scale factor. X is -2 minus A, which is also -2. So you're plugging in. Skylar, are you even paying attention to me today? You're so far away from me, you hadn't put that phone down. So -2 plus 2 is 0. 0 times 2 is 0. -2 plus 0 is -2. So it stays the same, which we knew was supposed to happen. But that's plugging it into the formula. That's just the X. Then you would have to do this part of the formula to get the Y. So B is 4. Okay. Plus K. Yep. K is our scale factor 2. Open parentheses. Then it has Y, which is 4, minus B, which is 4. 4 minus 4 is 0. 0 times 2 is 0. 4 plus 0 is 4. So that ordered pair is going to stay the same, which we knew, because that's the center of the dilation. Okay, so now to get a different point, you could do B. So A prime stays the same. That stays the same. Now let's do the same thing. This time our ordered pair is B, which is 1, 2. Okay, so this is X, this is Y. The center of dilation is -2, 4, which that's A, that's B, and K equals 2. So it's like you got to know all those different letters, what's what, to be able to plug into the formula. So the formula, first of all, says A, which is -2, plus K, which is 2, open parentheses, X, which is 1, minus A, which is -2. So see, I can't even remember the formula. It's just like super confusing, but if you've got it in front of you, you can do it. 1 plus 2 is 3. 2 times 3 is 6. -2 plus 6 is +4. So that's going to be the X value of B prime. Now you would do this part of the formula to get the Y. B is 4, plus K is 2. Open parentheses, Y is 2, minus B, which is 4. That's going to be -2 times 2, which is -4. 4 plus 4 is 0. So that gives you B prime, which is 4, 0. So you're literally just plugging into a formula, which is great if you can remember the formula. Now let me show you how to do it with a table. So if I was going to do this with a table, the first thing I would have is my pre-image. Okay, so I would have my ordered pairs, and I didn't really give myself enough space. Okay, so my A is -2, 4, B is 1, 2, and C is 1, 0, which I'm going to skip straight to C since that's where we're at. So the first thing that you have to do, step 1, is to subtract the center of dilation, okay, which that is going to be minus the center of dilation is -2, 4. So you're subtracting that, okay? So I'm going to do 1 minus -2. What's 1 minus -2? 3. Okay, 0 minus 4. What's 0 minus 4? So that's where it moved with the subtraction. Then after you do your subtraction, you do the dilation. Okay, what is our dilation this time? What's our scale factor? 2 times X, 2 times Y. What's 2 times 3? Okay, so that's going to be 6. What's 2 times -4? -8. And then you have to undo the subtraction, and you have to add the center of dilation. So that's going to be plus -2 minus 4. So these two undo each other. Start with the subtraction, then you add it back. What's 6 plus -2? It's going to be 4. And then what's -8 plus 4? And that is going to be C prime. Now, I don't care how you do it. It doesn't matter to me, okay? But you've got to do one of those two ways. You either have to use the formula or you have to use the table. But you're going to have to be able to do a dilation when it's not centered at the origin. Probably, fingers crossed, the one on your EOC is going to be centered around the origin, but it doesn't have to be, okay? So we got to be able to take that into consideration. So just remember to subtract it out. That gets you to the origin. Do your dilation, add it back in, okay? So that's doing that for now. And then it wants us on number 17 to graph the pre-image and graph the image. So I'm going to use the black to do the pre-image. That was at -2, 4, 1, 2, and 1, 0. Okay, so graph yours out. That's my pre-image. Do your best to have straight lines. And then I'm going to change pins so I can graph out the image. This point is still at negative 2, 4. Then we're at 4, 0, and 4, negative 4. So you can see the point that didn't change, the vertice that didn't change, is the one that's at the center of dilation. That one is not moving. Everyone else is moving. So that's what it means to multiply by a scale factor not centered at the origin. When it's centered at the origin, you literally just multiply x by whatever the scale factor is, multiply y by whatever the scale factor is, just like this, okay? But you can only do that when it's centered at the origin. So that's why this one you have to subtract it out, multiply, add it back in. All right, so let's look at number 18. 18 says triangle X, not X, triangle T, U, and V is mapped onto triangle T prime, U prime, V prime. Triangle TUV is mapped onto T prime, U prime, and V prime by a scale factor of 1/2 with a center at 2, negative 3. What are the coordinates of T prime, U prime, and V prime? Now, just to shorten this up and to keep our time relatively like sane, I want you guys to do U. Okay, figure out the new ordered pairs of U prime using the scale factor of 1/2 and the center of dilation at positive 2, negative 3. You can either use the formula or you can use a table. You're just doing U. Y'all do this. Oh. Okay, I set you up both ways because, again, what I'm good with you doing either one. Doesn't matter to me. If you did the table, the first thing you have to do is subtract the center of dilation. So what's -4 minus 2? What's 3 minus negative, I'm sorry, what's 2 minus -3? +5. Okay, because minus and negative is the same thing as plus. Everybody okay with that? Then your scale factor is 1/2. What's half of -6? What's half of 5? Okay. Then you have to add back the center of dilation. What's -3 plus 2? -1. What's 2.5 minus 3? -0.5. So that is your new point. That is u prime. Okay. Or if you did it this way, I have it all mapped out for you. I labeled everybody out. U is your XY, center of dilation is your AB. So A would be 2 plus 1/2 X minus A, which, wait, you don't do X. You gotta do -4 minus A, which is 2. So -6 times 1/2, which is 3. 3 plus 2 is, no, -3. So that's going to be -1. Okay. Then over here for B, B is -3 plus K, which is 1/2. Y is 2 minus B, which is -3. Instead of saying minus a negative, we say plus. 2 plus 5, or 2 plus 3 is 5. Half of 5 is 2.5. -3 plus 2.5 is -0.5. So again, you get the same thing. You just have to decide which way you like better and go with that. Okay? All right, your homework for today is on page 247. You are doing all of those except for 32. Now, there are 1, 2, 3, 4, 5, 6, 7 of those, but of those 7, the first 3 are just quick answers, won't take you very long. And then 28 through 31, you will have to do a little bit of sketch work, but they're all centered at the origin. So you don't have to worry about doing what we just talked about. You literally just apply the dilation to the X, multiply the X, multiply the Y. Okay? Make sure you submit that to Canvas. You guys that are in class don't have to submit your notes. If you did them, Mr. I'm on my phone all class. I got you, but I'm just saying y'all got to be doing your work in class. Okay? If you're in class, you just have to submit your homework. Those of my students that are not in class, you must submit your notes. If we stop taking notes, then we'll go back to everybody submitting everything. Okay, so make sure y'all are doing what you're supposed to be doing in class, taking care of business, not sleeping, doing your work. Any questions about grades? You know they're finalized. Those are already out. Okay.